Hello, viewers. In today's session, we are going to discuss a very important and conceptual problem from domain of functions, right? And here in this class, we are going to find out the domain of this function, which consists of the sum of two functions, right? So we have to find the domain of the function f of x, which is equal to square root of sine inverse of logarithm of x to the base 3 plus cos inverse of x minus 2, right? So in this class, we'll see how we can find out the domain of the sum of two functions, right? So here we'll make use of the concept of intersection of domains, right? So what we will do, we'll first find out the domain of this function, right? So let us take this function as g of x and this function as h of x, right? And we'll find out the domain of the function g of x, and let us denote the domain of this function by d1, and then we'll find out the domain of the function h of x. Let us call this domain as d2, and then we'll find out the intersection of d1 and d2, right? So the intersection of d1 and d2 is the domain of this function f of x, right? And we already know that by domain of a function, we mean the valid values of x, right? So all the values of x for which a function is defined is known as the domain of that function. So let us start. So let us first consider this function g of x. Now here we have a function inside the square root sign, right? And we know that for the validity of this function g of x, this function which is inside the square root sign must be greater than 0, right? So we must have a sine inverse of log of x to the base 3 must be greater than or equal to 0, right? So this is the first step while finding out the domain of this function g of x, right? Okay, now see here we have log of x to the base 3. So let us call this logarithm function as theta. So let us take it as theta. So we have log of x to the base 3 as theta. So we have this inequality as sine inverse theta is greater than or equal to 0, right? Now here we have the inverse function. Now see, from inverse trigonometric functions, we know that the principal value branch of sine inverse theta, it belongs to this interval, that is minus pi by 2 to pi by 2, including both these numbers, right? And this theta, it belongs to the interval minus 1 to 1. So it implies that theta must be greater than or equal to minus 1 but less than 1, right? Okay, now see, here sine inverse theta should be greater than or equal to 0, right? And here we are saying that this theta must lie between minus 1 and 0. So here we have minus 1, here we have 0, and here we have 1, right? So for sine inverse theta greater than or equal to 0, we have to take only this interval, right? Because when we take theta from 0 to 1, then only sine inverse theta must be greater than or equal to 0, right? So our theta must be greater than or equal to 0 but less than or equal to 1, and our theta is log of x to the base 3. So here we have log of x to the base 3, right? Okay, so now we have to solve this inequality. Now see, if we raise all these three numbers to the power of 3, then let us see what we get. So we'll take the number 0 to the power of 3. Then we have 3 raised to log of x to the base 3, and here we have 3 raised to 1. So what we have done here, we have raised these three numbers to this base 3, right? Because we know that the exponential function is an increasing function, so this is a very important point here. So the exponential function is an increasing function, so the direction of the inequality remains the same, right? And here we have 3 raised to log x to the base 3. So here we'll make use of this result, that is a raised to log of a, that is base a, x is equal to x, right, for all positive values of x. So here 3 raised to 0 is 1, and here we have simply x, because here this is 3, this is 3, so the value of a is 3, right? And here we have 3 raised to 1 is 3, right? So the domain of g of x is given by this inequality, that is x is greater than or equal to 1 but less than or equal to 3. So we can also write it like this, that is x belonging to the interval 1 to 3. So this is the domain d1, right? Now let us consider this function, that is h of x, which is cos inverse x minus 2, right? And here to obtain the domain of this function, we'll again make use of the concept of inverse trigonometric functions, right? So from inverse trigonometric functions, we know that the principal branch of cos inverse, say theta, it belongs to the interval that is 0 to pi, provided this theta, it belongs to the interval minus 1 to 1, right? So these are all important concepts. So theta must lie between minus 1 and 1. So here theta is x minus 2. So we can now substitute here theta is equal to x minus 2. So now we have this inequality, right? And we can easily solve this inequality by adding 2 throughout. So we have minus 1 plus 2, so that we can get rid of this minus 2. So we have x minus 2 plus 2. Here we have 1 plus 2. 2 minus 1 is 1. And here we have x. And here we have 2 plus 1, 3. Right? So the domain of this function is given by this inequality. And we can easily see that this inequality can also be written in the interval form, that is x belonging to the interval 1, 2, 3. Right? So this is the domain of this function h of x. So here we have got the domain d1 as 1 to 3 and d2 as 1 to 3. So we can see that the domain of both the functions are same, right? So this is very interesting here. The domain of both the functions are same, that is the interval 1 to 3. So if we calculate d1 intersection d2, then this is the interval 1 to 3 intersection interval 1 to 3, and we can get the same interval, that is 1 to 3, right? So the overall domain of this function, which may be denoted by d, is given by this interval, that is 1 to 3, right? So if we express this domain in the number line, so here we have minus infinity, here we have plus infinity, then here we have say 0, then we have 1, 2 and 3. Then this is our domain, of this function f of x, including both these points 1 and 3, right? So this is how, by making use of all these concepts, we can find out the domain of these kind of functions.